Hello, awesome algebra students. I hope you're having a great day. I am talking about in this video combining like terms. So first, let's make sure we're good with our vocabulary. We've talked about this vocabulary word term. A term, remember, is that little pieces of expressions or pieces of equations. So if I gave you this expression, 3x minus 2y plus 7 plus 6x plus 13, right? If I gave you this expression, you could say that it has 1, 2, 3, 4, 5 terms, right? It has 5 terms with it. Terms are those little chunks that are separated by either plus signs or minus signs. So here it has 5 terms. You might see an expression that's just 6x plus 2. Well, this expression only has 2 terms. It's much shorter. Okay, you could see an expression that has 30 terms, right? It could be super long. I don't think I'm going to give something to you like that, so you're welcome. But we have terms. They're separated by plus signs or minus signs. So today we're going to be looking at those terms, and we're going to be combining the like terms, right? The ones that are alike, the ones that are similar. So you could probably already look at this expression here, and you could say, out of those 5 terms, some of them are like terms. Some of them are not alike, but we're going to make sure that you are 100% able to identify those like terms, and then we're going to make sure that you can combine them appropriately. Okay, so I'm going to go ahead and delete this so we can move on to our actual notes for the day. You're going to see that the first thing in our notes is actually a picture, right? And these are some of my awesome favorite NBA players. So in this picture, I want to ask you a question. Who's on the same team? Right? How do you know they're on the same team? Who is on the same team as this lovely guy right here? Well, this guy shooting is on his team. This guy that we know very well is on his team. And this gentleman right here is on his team. How did we know that those 4 players are on the same team? All 4 of those players are wearing blue jerseys, right? They had the same jersey, which means that these other guys wearing the red are on the same team, right? These guys in the red jerseys are on the same team. Okay, so we have 2 separate teams here. That's what we're doing when we combine like terms, but we're doing it in different expressions and equations. You just did it on a picture here, right? You can combine those red players together in the jerseys or the blue jerseys together. Okay, you are able to do that by looking at their jersey. So now that we did that on a picture, let's look at an expression and see how is it different. Can we still tell who is on the same team? Now looking at this expression, who's on the same team? I ask you the same question, right? They don't have jersey numbers on, so you can't just look at the colors. However, I am using different colors to code them, right? I want to kind of give them a color. So if I look at this first term, this first term is a 7x squared. His jersey or what he is wearing is x squared. Do you see any more x squared jerseys in this expression? Not one here, but here is another x squared, a plus 5 x squared. And then there's one more x squared back here at the end. Those 3 all x squareds, the 7x squared, the 5x squared, the 1x squared, are all like terms, right? That's that new vocabulary word. They are like terms, right? They're all wearing x squared jerseys. Those I could combine, and we're going to talk about how to combine them in a second. We're just talking about, can you identify the like terms yet? So here is our like terms, but there's some other terms still in this expression that I haven't used. We can't forget about any of them. They're all in the game here. So let's see. This 2y, I used a different color, and I'm going to use a circle. Are there any players on his team? Are there any other y's? Well, here's a y right here. So that means that this 2y and the 6y can be on the same team. They're both wearing a y jersey, right? They both have that same variable. The last one, I can't forget about him, right? Because he's still in the game, is this plus 3x. There are no other just plain old x's. So he is on his team by himself, right? Sad day. But he is on his team. He cannot be combined with anybody else. So before you start combining your like terms, you have to be able to identify them. You did it with this expression here, and I'm going to write it out in words here on this next part, just so we can make sure we are clear cut and we know what like terms are so that way you can identify them 100% of the time. So combining like terms. In order to simplify expressions, sometimes you will need to combine the like terms. This is our why, right? This is what we are doing. We are combining like terms. The why behind it is because we want to simplify expressions. We want to make it simple. We want to make them smaller and easy for us to work with, right? We don't want these long expressions that have 30 terms. I want to change them to where it only has 2 terms because then it's much easier for me to work with. So the why is making it simple. We're simplifying expressions. This is important. This sentence right here, you're going to need at the end of today's lesson. So if I were you, I'd either write it down, I'd write it on a sticky note, put it on your brain, something. You need this sentence. It's what makes like terms. Like terms are terms that have the same blank and the same blank. So when we were doing that expression up above and we color-coded those like terms with the same jersey, those like terms had the same variable, right? A variable is another vocabulary word we talked about. It's the letter, right? They had the same X's or the same Y's or the same P's or Q's or whatever letter they had. And they had the same exponent. Exponents are those little numbers up at the top, right? It was like x squared. That was our exponent. So I had to make sure that they had both of those in common. If it was a 3x and a 3x squared, those are not like terms because this one is just an x and this one is an x squared. They don't have that same exponent. They're not like terms. If you had a 4x squared and a 3x squared, these are like terms because they have the same variable and they have that same exponent. Okay, so that's a very important sentence here. It's what makes like terms alike. They have to have the same variable, the same exponent. So now that we're on the same page about how to identify the like terms and know what the like terms are, let's go ahead and put it to practice. Let's go ahead and take those like terms. Let's practice identifying them, and then let's also practice combining them. I'm going to come back to this one at the very end so that we can do that. That's like our challenge question, right? It has a whole bunch of different ones. So here is our first 3 questions, and we're going to have 5, total of 5 in this video. So here's our first 3. When we combine like terms, we use the coefficients to help us add or subtract. So this is now not just identifying, but now we're combining. So when we combine, we either add or subtract, and we use the coefficients. Now coefficients are, if I had 3x, that 3 is the coefficient. If I had a 6y squared, that 6 is the coefficient. We're using those numbers, and we're adding and subtracting those numbers. The variables and exponents do not change. Guys, that's like their jersey. Remember that x squared or the y is like their jersey. They don't change their jersey. We just change the coefficient. We're just adding or subtracting them together. You're going to see what I mean when we do number 1 here. So number 1, I'm going to look for like terms. My first term is a 3x. Does this 5x have the same variable? Yep. Does it have the same exponent? Is there an exponent up there? No. So yes, these are like terms, a 3x and a 5x. So what you do is you combine them. So I'd like to rewrite it below. 3x and a positive 5x. When I combine those, well, 3 and 5 make 8x. That 8x is your answer. What you did is you took those 2 terms and you combined them to make 1 term. Didn't you make it simpler? That was the why, right? Is to make things smaller, make it simpler. Now you only have 1 term in your answer. You made it smaller. Great job. You just combined like terms, right? Now that one was an easy one, right? It's going to get a little bit harder than that, but that's all it is, combining like term. So number 2, I have a negative 5y. Is this one a like term? It sure is. It's a y. So I'm going to combine them. And be careful because now I have a negative in here. So when I combine these, negative 5y plus 2y still puts me at negative 3y. That is my answer. My answer is negative 3y. There was no other players up here in this expression for me to combine. That was it. You made the 2 into a 1 term. Now let's look at this third example. Here's where we step it up a bit, right? There's 3 terms here. Let's see what we do with 3 terms. Let's see, is it any different? I have a 4x squared. Are there any more x squareds? There is, right here. This one is not an x squared, so I cannot say it's a like term. I'm only going to combine the like terms. So 4x squared plus 2x squared. Well, when I combine that, 4x squared and 2x squared makes 6x squared. So when I combine those two, I got 6x squared. Now, can we forget about that other player there? Can we forget about this 6y? We can't forget about him. This 6y has no like terms with it here. There's none that are like terms. So you have to just bring it down and include it in your answer, right? There was no other like terms to combine, so I can't forget about it. I have to bring it down still. So now you went from 3 terms to 2 terms. You still made it simpler, right? You combined what you can, right? That's all you're doing here. If you can combine it, do it. If you can't combine it, keep it in your answer. You can't forget about it. So that was our first 3. We got through them pretty quickly. I'm going to show us our last 3 examples that we're doing here, and then we're going to go back to that challenge question. So here are our number 4 and number 5. Number 4, we have an 8x squared. And look, are there any more x squareds here? There is, right here. And make sure you take note, when I box these in or circle them or highlight, whatever you need to do to color code, I always include that sign that's right in front. So when I combine these, 8x squared, and this one is a positive 3x squared, when I combine those, I get 11x squared. So I know that that's going to be in my answer, 11x squared. Then I look at the next term, a 3x. Are there any more x's? There are right here. And look, I'm including that negative sign or this minus sign in that circle. So when I combine those, 3x, negative 7x, when I combine those, I am not adding them. That's a subtraction symbol. So 3x minus 7x. That puts me in negatives. Gives me negative 4x. That's okay. I write in my answer negative 4x. But I cannot forget about that last player up there, right? He does not have any like terms. There's nobody that's a like term for him, so you just have to bring him down in your answer. You can't forget about him. So there is your answer. You went from 1, 2, 3, 4, 5 terms down to 3 terms. You made it simpler. You simplified them. You're going to start becoming so good at this to where you don't have to show that work that was down here, right? You are just going to be so good that you say, here's a like term, here's a like term, 8 plus 3 is 11x squared, and then you say, here is a like term, here is a like term, that gives me negative 4x, and then this one doesn't have a like term, so I just bring it down and it's plus 5, and that's my answer, right? You're going to become so good at this to where you don't have to do that extra step writing down here of where you're adding and subtracting. I like to do it so you can see my process, right? Where did I get 11x squared? Where did I get negative 4? I write it so you can see it, okay? If you're already at this point where you don't have to write it, then that's awesome, right? As long as you're getting the right answers, I am all for it, okay? So number 5, our last one here. 3x squared. Look for any more x squareds in this long expression here. I don't see any more x squareds, so I'm just going to bring that one down to put it in my answer. I'm going to change my colors because I like to color code these for like terms. This 2y. Is there any more y's here? Well, there's a couple. 6y, and negative 4y. There's 3 like terms there, so I'm going to combine them down here at the bottom. I have a positive 2y plus 6y minus 4y. That's why it's important to include those symbols that are right in front. So 2 plus 6 gives me 8 minus 4. 8 minus 4 is 4. So I'm left with 4y. And this is a positive 4y. We have to include that. Positive 4y. Then I keep going and I keep looking for more like terms and I say, there's an x there. There's no more x's though that I can combine it with, so I just have to bring it down and include it in my answer. But there's still some players there, right? There's still a plus 5 and there's still a minus 7. And they're like terms, so I'm going to combine them. A positive 5 and a minus 7. Ooh, 5 minus 7 is negative 2. Then I bring that into my answer. I combined what I could. Some of them I couldn't combine. Some of them I could combine 3 things. But I went from 1, 2, 3, 4, 5, 6, 7. I went from 7 terms down to 4. That's going to help you when you keep going forward and you do the extra math, because now you only have 4 terms to work with. You don't have to work with 7 terms. It's a little bit simpler for you, okay? Sometimes you might be able to combine all 7 terms down to 1 term, and that will make things extra helpful, right? Extra simple for you. So we did our combining like terms. I'm going to go back to that original example that we had, so that way we can make sure that we get that challenge question. So here it was. Please remember that you're going to need this sentence at the end of today's lesson. So like terms are terms that have the same variable and the same exponent. So this doesn't really look like a challenge question. You did one where there was 7, right? This shouldn't be a challenge. So I can say 7x squared, and a 5x squared and a 1x squared are like terms. So when I combine those, 7 and positive 5 and positive 1, what do we get? 13x squared. Then I look for my next ones, 2y, 6y. They're both positive, so when I combine them, I get 8y. And then lastly, this 3x is by himself, but I have to include him in my answer. There we go. We just combined what we could and combined those like terms. Remember, if you're not at the point yet, I highly encourage you to still write out the math below it, just like we were doing in our examples, because you need to make sure that you're paying attention to negative and positives when you're combining them. Okay, highly encourage that. Please make sure you take note of this sentence. They have to have the same variable. They have to have the same exponent. If they don't, they're not like terms. Keep up the great math, guys. Your teachers love to see your beautiful work. Ask us if you have any questions, and then have a beautiful day. Bye, guys.